Hi, I'm Heidi Jauhiainen. I'm really sorry I cannot be with you live. Today, I want to tell you about using encoding to produce machine-readable hieroglyphic texts. Now, we all know that in order to use digital methods for researching texts, the texts must be machine-readable. And for historical research, there are several corpora of machine-readable texts. And for example, Assyriology has corpora of cuneiform texts that are openly downloadable and reusable, for example, at the Open Richly Annotated Cuneiform Corpus. Egyptology also has several online corpora, where it is possible to search and study words and texts. But there are no corpora that one can download for one's own use, and this hinders the digital study of ancient Egyptian texts. In the machine-readable texts for Egyptology project at the University of Helsinki, the aim is to produce new machine-readable hieroglyphic texts by building a method for semi-automatic transliteration. But first, I need some machine-readable text to develop and test the method. This is not as straightforward with hieroglyphs as with some other scripts. And in this presentation, I will first talk about hieroglyphic texts and why encoding is needed for making them machine-readable. To finish, I will tell how I encode hieroglyphic texts and about the tool I'm building to help structure the texts ready for publishing. Hieroglyphs were generally used in monumental texts, where they could be written in different directions, often depending on the pictures. For example, here, the name of the king is written in vertical columns from right to left, and the name of the god Amun-Re from left to right in similar columns. When writing literature or letters or administrative texts, the ancient Egyptians usually wrote on a papyrus, or as here, on a so-called ostracon, a piece of limestone or pottery. On these writing materials, they used cursive handwriting, which the Greek later called hieratic writing. Hieratic was usually written from right to left, and the writing was based on the hieroglyphic writing, and Egyptologists generally transcribe the hieratic texts to hieroglyphs when studying and publishing them. Different hieroglyphic graphics, or signs as they are usually called, different signs have different functions, and one sign can have varying functions in different contexts. Signs can be used as logograms, referring to entire words. But many signs function as phonograms, representing 1 to 3, sometimes even 4 phonemes. Ancient Egyptian belongs to the Afro-Asiatic languages, and like Arabic or Akkadian, only consonant roots are represented in writing. Both logograms and phonograms could be used to write words that had nothing to do with the object they depict. Certain signs have several different phonetic values, and several signs could have the same phonetic value. Therefore, signs were combined and phonetic complements were used for showing which phonetic value was meant. And in order to tell the different words with the same phonetic value apart, classifiers were added to the end of the word. For example, here the first sign in each word depicts a chisel, and it has 2 phonetic values, Aleph, bas, plus B, and M plus R. With Ab, the leg width value B is usually used, while Mer has the owl for M and mouth for R. And different words have different classifiers at the end. One way of producing machine-readable hieroglyphic texts would be to use Unicode, which has since 2009 included over 1,000 hieroglyphic signs. Now, hieroglyphic signs were often grouped so that one is above another one, and they could be nested or even one over another. With the Unicode, there was no way of positioning the signs properly. In 2019, the so-called format control characters were introduced in Unicode version 12, and now it is, in principle at least, possible to position the signs. But producing hieroglyphic texts with Unicode hex character codes is not easy, and basically one needs a software to do it. And at least on a Mac, it's still impossible to position the signs as the format control characters are not available. Transliteration of the hieroglyphic texts with Latin characters would be the machine-readable form preferred by Egyptologists, as this is what they are used to seeing when they analyze the texts. But transliteration is already an interpretation of the text, and it does not have the information on the signs that were used for producing the words. Some publishers have their own hieroglyphic typesetting, but mostly texts used to be drawn by hand, even in books. Nowadays, the texts are often encoded with Latin letters and Arabic numbers, and these codes come from the so-called Gardiner sign list, and the letters refer to various categories of signs, while each sign has a number within the category it belongs to. Here the first sign depicts the sun, and it belongs to the group N, sky, earth, and water. The most often used encoding is called manual decodage. It has conventions of placing signs above and next to each other. Different software for producing hieroglyphic text use slightly different strategies for positioning more complicated sign groups. The encoded texts are machine readable, but in Egyptology, they are only used for producing pictures for books or text to be posted online, and the encoded texts are not published or even preserved. In order to produce machine-readable hieroglyphic texts, I have chosen to start by encoding hieroglyphic texts using a software called JSES. JSES is an open-source Java-based word processor for producing hieroglyphic texts. The text produced can be exported as pictures or PDFs, but as the aim is to produce machine-readable texts, the attention is on the encoding. The encoded texts will be published for future use in TEI format, which is the XML structure preferred in Egyptology. For turning the encoded text to TEI files, I am building a tool called CLI2MD. As the project is ongoing, only the first simple form of the tool is available at the moment. Now, from JSES, it is possible to copy out the encoding and paste it in a new file, but that's of course complicated. So it is best to export the encoding directly from the binary files produced in JSES. And these binary files have an extension, a GLI, hence the name of the tool. Version 1.0 of CLI2MD extracts the manual decodage encoding from the binary file, cleans the text, and writes it to a new file. This cleaned encoding can be used for building and testing the method for semi-automatic transliteration. And the future versions of the tool will then build TEI files with encoded hieroglyphic texts, which are annotated with transliteration and Unicode characters. I'm very sorry I cannot be there to answer your questions, but please don't hesitate to contact me by email if you have any comments or questions. Thank you for listening.